Hey, everybody, and welcome to the deep dive. We're going to be talking about cloud native development and Kubernetes today. And to help us out, we've got a really great book here called Cloud Native DevOps with Kubernetes by John Rundle and Justin Dominguez. This book is really cool because it takes all these really complex ideas and breaks them down. So whether you're like a hardcore coder or just someone who's curious about how software gets built and deployed in this modern age, it's a really accessible read. And we're going to be exploring a whole bunch of cool stuff today, like how cloud computing has changed over time and the impact of containers. And then we'll get into the world of Kubernetes clusters. And then we'll see how all of this actually connects to what developers and operations teams are doing on a daily basis. And to guide us on this journey, we've got a true cloud native expert with us. So let's kick things off with the cloud native revolution. The book kind of paints this picture of how businesses used to handle their IT infrastructure, which seems kind of wild now that I think about it.
Yeah, it's pretty different from how things work today. Like back in the day, businesses would spend a ton of money on actual physical servers and hardware, like a huge upfront investment.
Hmm.
It was all about capital expenditures.
Yeah, it's like buying a house instead of renting an apartment. You're stuck with that infrastructure even if you're not fully using it.
Exactly. And then cloud computing comes along and totally changes the game. It's like switching to a subscription service for your IT needs. You just pay for what you actually use.
So instead of owning a house, you're renting a flexible living space that you can adjust to your needs. I can see why businesses would love that, especially startups that need to scale up quickly.
Oh, absolutely. And the way this evolution happened is pretty interesting. It started with infrastructure as a service, which was basically renting virtual servers in the cloud. But it didn't end there.
So where did it go from there?
The cloud evolved to a point where you could basically outsource almost any software that you weren't writing in-house. Think like operating systems, databases, clustering, all that stuff was handled by managed services, so businesses could focus on what they were really good at.
It's like having a team of specialists taking care of all the infrastructure stuff so you can just concentrate on building and innovating.
Precisely. And this leads us to another important piece of the puzzle, DevOps. DevOps bridges the gap between software development and IT operations. It's all about collaboration, automation, and continuous feedback.
So it's not just about the technology, but how teams work together as well.
Exactly. And this is relevant to everyone in the tech world, regardless of your specific role. DevOps practices have had a huge impact on how software is developed and delivered today.
It's all about being agile and adapting to changes quickly, which is crucial in today's fast-paced world.
Absolutely. Now, let's talk about a key ingredient in this cloud-native recipe. Containers. The book makes this really cool comparison between software containers and those big shipping containers that revolutionize global trade.
That's a really interesting analogy. I can see the similarities. Both types of containers make it easier to transport and manage things efficiently.
Exactly. Like imagine trying to ship goods all over the world without standardized containers. It would be a logistical nightmare. Software containers bring that same standardization and efficiency to deploying software. They package the application with all its dependencies and configurations, so it runs consistently across different environments.
Yeah, you know how sometimes your application works perfectly on your computer, but then it breaks when it's deployed to a server? Sounds like containers could be the solution to that.
That's exactly what they solve. By packaging everything neatly, containers eliminate those inconsistencies and make deployment much smoother.
It's like having a self-contained unit that guarantees your app will behave the same way wherever it goes.
Right. On a larger scale, containers are the building blocks of this whole cloud-native world. They make it much simpler to create and manage these complex distributed systems.
So we've got the cloud DevOps and containers. All the pieces are coming together. But to orchestrate this whole symphony of cloud-native goodness, we need something else, right?
Yes, and that's where Kubernetes comes in. It's like the conductor making sure all the instruments are playing in harmony.
Okay, so tell me more about this Kubernetes thing.
Kubernetes is like the operating system for the cloud-native world. It automates container deployment, scaling, networking, and management.
Wow, so it takes care of all the behind-the-scenes stuff, so developers can just focus on building great applications. But how does it actually work? The book mentions these things called pods, deployments, and services. Can you break those down for me?
Sure. Imagine a pod as the smallest unit you can deploy in Kubernetes. It's basically a wrapper around one or more containers. They all share resources like storage and networking so the containers can work together smoothly.
So it's like a little neighborhood where containers can interact and collaborate.
That's a great way to put it. And a deployment makes sure you always have the right number of these neighborhoods running. It's like a blueprint for your application's infrastructure, guaranteeing redundancy and high availability.
And what about these services?
A service acts like a traffic cop. It makes sure that requests go to the correct pods, even if they're scaling up or down or moving around. Think of it like a dedicated phone number for a department, even if the people answering the phone might change.
Makes sense. The book also says that Kubernetes can run on pretty much anything cloud providers, on-premises data centers, even bare metal servers. It seems super versatile.
That's one of the best things about it. A key feature is the Kubernetes scheduler. This intelligent system decides which physical server is the best fit for each pod based on its resource requirements. It's all about using resources efficiently and preventing any single server from getting overloaded.
So Kubernetes is making all these complex decisions behind the scenes and optimizing everything for us.
Exactly. But running Kubernetes clusters in the real world can get pretty complex, especially when you're dealing with production environments and mission-critical applications.
So what are our options for running Kubernetes clusters? The book talks about a few different approaches, right?
There are self-hosted options where you manage everything yourself. But for a lot of organizations, managed services like Google Kubernetes Engine or Amazon Elastic Container Service for Kubernetes are a much better option.
What makes these managed services so appealing?
They take care of a lot of the complexity involved in setting up and maintaining those Kubernetes clusters, so you can focus on deploying and managing your applications.
It sounds like a great way to get started without needing to become a Kubernetes expert overnight.
You got it. But even with these managed services, there's still a lot to learn about how to effectively manage those clusters.
Well, luckily we have this book as our guide and you to help us navigate through it all.
That's right. And we're just getting started. Next, we'll delve into the tools and techniques that can make your Kubernetes workflows more efficient and help you master the art of container orchestration.
Welcome back. So we're continuing our deep dive into Kubernetes, and one thing that's really struck me is just how much Kubernetes automates. It's like having this whole team of experts working behind the scenes, making sure everything's running smoothly.
Yeah, absolutely. And that level of automation is super important when you're dealing with complex distributed systems. But it also creates some new challenges, especially when you're trying to understand how those systems are actually performing.
Yeah, that makes sense. It's like having a self-driving car.
Yeah.
It's great until something goes wrong, and then you have to figure out how to troubleshoot a system that you don't really control.
That's a great analogy. And that's where observability comes in. It's not just about monitoring like whether things are up or down. It's about having the insights to understand why things are happening inside your system.
Right. The book talks about the limitations of traditional monitoring, especially for these cloud-native applications. Can you expand on that a little?
Sure, traditional monitoring often relies on like black box checks, pinging a website to see if it responds, for example. But cloud-native applications are rarely completely up or down. They might have like partial failures or performance issues that those simple checks wouldn't catch.
So it's like checking if the lights are on in a house, but not knowing if the plumbing's working or if there's a fire in the attic.
Exactly. We need to go beyond those surface level checks and get a deeper understanding of what's happening inside.
Okay, so the book talks about logs, metrics, and tracing as being crucial for observability. Can you break those down for us?
Think of logs as like the written record of events in your application. They can be super useful for troubleshooting, but they can get overwhelming when you're dealing with large distributed systems.
Yeah, I can imagine trying to sort through gigabytes of log data would be like searching for a needle in a haystack.
That's where metrics come in. Metrics are numerical measurements that give you this constant pulse on your system's health and performance. Stuff like request rates, error rates, latency. Those vital signs that can help you spot trends and potential problems.
So it's like having a dashboard with all these gauges and dials showing you how your application is doing in real time.
Exactly. And then we have tracing, which is especially useful in distributed systems where a single request might hop across multiple services. Tracing lets you follow that request's path, pinpointing where things might be slowing down or going wrong.
Oh, wow. So tracing is like having a detective on the case, tracking down the root cause of a problem.
Exactly. Now, even though all these tools give us a really powerful view into our systems, we still need to think about application-level health checks.
What do you mean by that?
Well, Kubernetes has its own built-in health checks, but those are pretty basic, like just checking if a container is running. We need applications to be more introspective and tell us about their internal health.
Oh, so it's like asking the application, are you feeling okay, instead of just, are you alive?
Exactly. A healthy application should be able to report on things like database connections, dependencies on other services, and even key performance indicators.
Right. So that gives us a much better understanding of the application's overall well-being. beyond just whether it's technically running.
Exactly. Now, once we have this observability in place, we can start thinking about monitoring, actively tracking those metrics and setting up alerts.
Yeah, but I imagine it would be easy to get overwhelmed with alerts.
Definitely. That's why it's super important to be strategic about what you monitor and how you set up your alerts. You don't want to get alert fatigue.
So how do you strike that balance?
Alerts should be reserved for critical situations where you need to take immediate action. They should be urgent, important, and actionable. For everything else, you can rely on asynchronous notifications that can be addressed during regular working hours.
Right. So it's about prioritizing and making sure the right people get notified about the right things at the right time.
Precisely. Now, when it comes to monitoring tools, Prometheus has become like the gold standard in the cloud-native world.
Yeah, I've heard of Prometheus. What makes it so special?
Prometheus is a really powerful open-source monitoring system that was specifically designed for cloud-native environments. It's amazing at collecting, storing, and analyzing metrics, and it works really well with a wide range of tools and services, like Grafana, which is great for creating visualizations and dashboards.
So it's like this central nervous system for your whole infrastructure.
Yeah.
Collecting data and giving you insights into what's going on.
Exactly. And if you're not ready to manage your own monitoring system, there are some great managed services out there. Things like Google Stackdriver, Amazon CloudWatch, and Datadog.
So there are options for every level of comfort and experience.
Exactly. And the cool thing is that many of these tools can actually work together, making it easier to integrate them into your existing workflows.
Well, it sounds like observability and monitoring are absolutely crucial for anyone working with Kubernetes.
Yeah.
It's not just about deploying applications, but understanding how they're performing and being able to troubleshoot problems effectively.
You nailed it. These concepts are essential for making sure your cloud-native applications are reliable and resilient.
Okay, well, with all this talk about monitoring and troubleshooting, I'm really excited to dive into the next part of the book, which focuses on actually managing pods and containers within Kubernetes.
Sounds good. Let's explore those building blocks and see how they all fit together to create these powerful, scalable systems.
Welcome back to our deep dive into the world of cloud-native development with Kubernetes. We've covered a lot of ground, from the evolution of cloud computing to the importance of observability and monitoring. And now it's time to zoom in on the core of Kubernetes pods and containers.
Right. We've talked about them in a general sense, but now let's really break down what they are and how they work together.
I'm ready to get into the details.
All right.
So remind me again, what exactly is a pod in Kubernetes?
A pod is the smallest unit that you can deploy in Kubernetes. It's like this little container village. It provides this shared environment for one or more containers to live and work together.
Okay, so why do we need this village? Why not just deploy containers directly?
Well, pods encapsulate those containers and give them these extra features that make it much easier to manage and orchestrate them. For example, pods make sure that all the containers inside them are always on the same physical server. That's super important for applications where the containers need to communicate with each other really quickly.
It makes sense that containers that need to talk to each other should be close neighbors.
Exactly. And pods also handle things like environment variables, storage volumes, and networking. They just make life easier for those containers.
The book also mentions that a pod usually has one main container that runs the main application, plus maybe some helper containers. What are some real-world examples of that?
Imagine you have a web application container. You might also have this sidecar container that handles logging. It would collect all the logs from the web application compiler and send them to a centralized logging system.
That's a good example. So the sidecar is like this little helper taking care of a specific task, so the main container can focus on its job.
Exactly. You could also have a sidecar acting as a proxy routing traffic to the main container, or handling things like TLS termination.
It sounds like this sidecar concept adds a lot of flexibility and modularity to how we design applications.
Definitely. It lets you break down these complex applications into smaller, more manageable pieces. But this also brings up an important point: container security. We need to make sure that those containers are locked down.
That makes sense. What are some best practices for making sure those containers are secure?
One of the most important things is to avoid running containers as the root user. It's like giving everyone on a ship the captain's key. Not a good idea.
Right. We want to limit those containers' privileges to only what they absolutely need to do their job.
Exactly. And Kubernetes has these features like security contexts and pod security policies that help you enforce those limits. You can control stuff like file system, permissions, network access, and you can even prevent containers from gaining more privileges than they should have.
It sounds like Kubernetes has a lot of built-in security features to help protect our applications.
Definitely. Now let's switch gears a bit and talk about these container image specifications. Those long strings that include the registry hostname, the repository, the image name, and the tag, they can look kind of scary at first.
Yeah, I've definitely seen those and wondered what all those different parts meant.
It's all about understanding the structure.
Hmm.
The registry hostname tells you where the image is stored, like Docker Hub. The repository is like a folder within that registry, and the image name tells you which specific image it is. And the tag is important because it specifies a particular version of the image.
The book really stresses how important it is to use those specific tags instead of just relying on the latest tag.
Totally. Using those specific tags is crucial if you want reproducible deployments. Otherwise, you're basically just hoping you get the right version of the image. And that can lead to inconsistencies and all sorts of weird behavior.
Right. So being specific about those tags is all about maintaining control and predictability.
Exactly. Now let's move on to managing those pods in Kubernetes. We've talked about deployments, which are really useful for managing those container villages. But there are also other controllers like replica sets jobs and stateful sets. It can be hard to keep them all straight.
All right, let's untangle this web of controllers.
Yeah.
What are the key differences?
Think of controllers as the automated workforce of Kubernetes. They make sure that your pods are always in the state that you want them to be. Replica sets are the simplest kind of controller. They make sure you always have a specific number of identical pods running. Deployments build on those replica sets and add features like rolling updates and rollbacks, so you can upgrade your application seamlessly.
So replica sets are the foundation, and then deployments give you more advanced management options.
Exactly. Then we have jobs, which are perfect for tasks that have a clear start and end, like running some batch processing or a database migration.
So if you have a task that doesn't need to run all the time, a job is the way to go.
Right.
Yeah.
And finally, we have stateful sets, which are specifically for stateful applications like databases.
Okay, so why do stateful applications need a special kind of controller?
Because they need persistent storage and stable network identities. Stateful sets make sure that those pods are created and deleted in a specific order, so their state is preserved even if they need to restart.
That's really cool how Kubernetes has all these specialized tools for different kinds of applications.
It's all about giving you the flexibility and control you need to manage all kinds of workloads.
Now, the book also talks about how those pods are scheduled and placed within the cluster, and that seems like a whole other level of complexity. There are node affinities, taints, and tolerations, pod affinities. It's a lot.
It's all about understanding how those pods interact with the physical servers in your cluster, which are called nodes. Node affinities let you specify preferences or requirements for which nodes a pod should run on. Like maybe you have a pod that needs really fast storage, so you want to make sure it's placed on a node with SSDs.
So it's kind of like choosing the right neighborhood for your container village based on its needs.
Exactly. Taints and tolerations are a bit like a matchmaking system. Taints mark those nodes with special attributes, and tolerations let pods say, hey, I can handle that, so you can control which pods can run on which nodes and make sure that your workloads are placed correctly.
And then there are pod affinities and anti-affinities. Those are about how pods relate to each other, right?
Yep. Pod affinities let you say that you want certain pods to be co-located on the same node, while anti-affinities do the opposite. They spread pods across different nodes for redundancy.
So it's like deciding whether your container villages should be close together or spread out for safety.
Exactly. And last but not least, we have daemon sets. They make sure that there's a pod running on every node in your cluster.
When would you use a daemon set?
They're perfect for things like monitoring agents or logging daemons that need to be running on every node to collect data or do system-level tasks.
It's amazing how much control Kubernetes gives you over how your applications are deployed and managed.
It is, and we've really only scratched the surface. The book goes into even more detail on topics like ingress resources for managing external access to services, service meshes for better communication between microservices, and even custom resource definitions for extending Kubernetes to meet specific needs.
Wow, it seems like the possibilities are endless. This deep dive has been a real eye-opener for me. I have to admit, I was kind of intimidated by Kubernetes at first, but now I'm actually excited to explore it more.
That's great. It is a complex system, but it's also incredibly powerful and flexible. And the best part is you don't have to learn everything all at once. Just start with the basics, experiment, and don't be afraid to ask the Kubernetes community for help. It's a really welcoming and supportive community.
That's encouraging to hear. This book has been such a great guide with clear explanations and helpful examples.
It's a valuable resource for anyone working with Kubernetes, no matter their skill level.
Well, on that note, we've come to the end of our Kubernetes journey. We hope you've enjoyed this deep dive into the world of cloud-native development. Until next time, keep exploring, keep learning, and keep diving deep.